So we're doing our last chapter, which is chapter 2.5 for, not sure what happened here. Okay, yeah, interpreting graphs. And we're going to talk a little bit about making appropriate graphs and how to identify misleading graphs. So remember that for any type of data, you want to make an appropriate graph. Okay, this is important, that you must make an appropriate graph. And appropriate graphs, for numerical data, we know that we use dot plots, histograms, and stem plots, while for categorical data, we use pie charts or bar graphs. Recall also that for numerical data, we use shape, center, and spread. And for categorical data, we use mode and variability. Now, here's where I want to talk about a little bit about well-designed graphs to see patterns, but misleading graphs play tricks on our eyes and lead to wrong conclusion. For example, you can have to watch for inappropriate scaling starting at a value other than 0. If you look at these two graphs here, in bar chart A, the graph apparently shows a dramatic decline in the number of violent crimes since 2007. The origin for the vertical axis causes this to be misleading because they didn't start it at 0. Chart B is the correct graph. It's not misleading. It starts at 0, and you can see there's actually a very little decline compared to this dramatic decline that you're seeing in the first graph. The second type of misleading you have to watch for is using icons of different sizes rather than bars. And this you can see in this picture here. In graph A represents 7.1 billion sold, graph B represents 6.5 billion, and C represents 5.8, and D represents 4.9. Here, the icons used are misleading, and they tend to give an inappropriate graph that's not applicable to the situation. It's using this home icon that's larger than the number actually represents. All right, so let's speak quickly about the homework here. I'm not going to tell you questions 1 and 2, but the first step in investigating data from your notes is always to make an appropriate graph. And the most common trick, of course, is to change, not use a 0 axis, which is likely answer C here. Change the scale on the vertical axis so that it doesn't start on 0, as we saw in the 2 problems a minute ago. Now, we can move on to what the problems actually look like. Here it says the accompanying graph shows distribution of data on whether the houses in a large neighborhood have a garage. One indicates the house has a garage, and 0 indicates the house does not have a garage. So, first question, is the graph a bar graph or a histogram? So this is clearly a histogram because the bars touch, okay? It can't be a bar graph because in the bar graphs, the bars do not touch. How could the graph be improved? So I think that you can improve this graph by using a bar graph because it's categorical, right? And we could use a bar graph or even a pie chart to make this data better. So um, we don't have to look too far for this answer. The graph could be improved by making it into a bar graph or a pie chart. This would make the variable garage seen as categories and not as numbers, and would actually be able to see the percentage divided up, um, between 60 and 10%, instead of between the frequency rather between 70 and 10, rather than what's shown on this histogram here. Question 4, student has gathered data on self-perceived body image where 1 represents underweight and 2 represents about right, 3 represents overweight. The graph is shown. Again, a better choice here, this is an obvious histogram. A better choice would be a bar graph or a pie chart, because we're talking about 3 categories: underweight, overweight, and just right. So definitely a bar graph or a pie chart. I think answer B would just, you don't have to look too far to find the answer here because the data set is categorical. The numbers 1, 2, and 3 represents categories, so a histogram should not be used. In question 5, the graph shows the age of females labeled 1 and males labeled 0 who are majoring in psychology at a 4-year college. Is this a histogram or a bar chart? Since the bars are separated, this is clearly a bar chart. And what type of graph would be more appropriate? So now we're dealing with several types of data, not 3 categories of data. We're dealing with numerical data. So a pair of histograms might be more appropriate. You don't want to use either a pie chart or a Pareto chart. And the current graph is certainly not the best choice to show the graph and the data in the appropriate. In fact, 2 histograms on a pair of dot plots would probably, or a pair of even dot plots would be appropriate with a common horizontal axis to give the best representation of this. A bar graph, really, you can't tell what's going on in this picture. And finally, question 6. So here we have, let me see if I can make that a little smaller. Yeah. Refer to the accompanying graph, which shows the time spent on a typical day talking on the cell phone for some men and women. Each person was asked to choose the one of 4 intervals that best fitted the amount of time they spent on the phone. For example, 0 to 4 hours, 12 hours, and so on. So you can look at this and see that 0 to 4 hours, 4 to 8 hours, 8 to 12 hours, and 12 plus hours. And we're going to try to identify the 2 variables. One variable is male or female, so gender. Which is, of course, categorical. Since it describes qualities, it's qualitative data. And the other variable is time range. Now, arguably, you might want to say that time range is numerical, but we're talking about singular time range here and not numerical data as such, not how many time each person spends talking on the phone, but groups of people talking on the phone. So this is also categorical. And it is also describing qualities, not quantities, qualities. Okay, so both sets of this data, the gender and the time range, are categorical in nature. Clearly, the bars are separated, so this is a bar graph, and it's best since both um, choices are categorical in nature. Now, the question continues, and we have to be careful what it's asking us here. If you had actual numbers of hours for each person rather than just an interval, what type of graph would you use to display the actual number of hours? In that case, because the data would be numerical, we would use histograms. Since the time would be a numerical variable and not a categorical data. Okay, if we had actual data showing how much time each person spent rather than groups of data, summary of data that were categorical. And then compare the modes of the two distributions and interpret what you discover. What does this say about the difference between men and women's cell phone use? So the mode for women, the highest is in the 428 category right there, 428, because it is the tallest for women, of course, not for men. The question is asking about for women, um, and then the mode for men, the tallest would be the 0 to 4 category, because it's the tallest for men, tallest bar for men. So the distributions show that women talk more on their cell phone based on this group of data.